Okay, so if you're working on this question here, this is the step where you want to take some care that you don't go too quickly. Right here where I'm about to square them, this is what people sometimes forget, is that I need to apply that square, that exponent, to both terms. So that means I'm actually going to end up here with 4 times x minus 3 after I square both terms in there. So that's why that question is there. It's to remind you not to forget. So then that means I'll have 4x minus 12 equals 36 minus 12x plus x squared. And if I collect my like terms to solve this, I'll end up with x squared minus 16x plus 48. Okay, so let's see here. 4 and 12 I think will work. So x minus 4, x minus 12, and that gives me 2 possibilities, 4 or 12. So I'll try them again versus the original equation. Does 4 plus 2 root 4 minus 3 equal to 6? That's correct. So I will keep that as one of my solutions. And for the last one, does 12 work as a solution? Well, unfortunately, it's not going to work. That looks like it's going to be too big. So it's going to be one that I reject. Okay. So the only solution I found for this was x equals to 4. Okay, so as like with the absolute value equations, it gets a little trickier when we throw in an extra radical sign. I'll show you why. It's not that bad, but basically you have to kind of brace yourself and know that it's going to get a little bit worse before it gets better. So let me show you what the strategy is going to be this time. It's going to be the same as before. We want to try to isolate as much as we can. So let's start by trying to isolate. That means I would have something like this. It'll work just the same if we would have moved the root x over instead. You could move either piece, but you'll see why I want the 2 pieces to be separate in just a minute here. Okay, so this is a real key step here. If we forget to do this, the method's going to fall apart. I'll show you why. Okay, let's square both sides and see what happens. So if you remember the pattern here, it definitely helps because then it can make the expanding go a little bit quicker. But now that we take a look at where we're at compared to where we started, when we started, how many square roots did we have? 2 square roots. Now we have 1. That's gotten us back to what we did just a minute ago. So even though it got worse, by splitting it to either side, I was able to remove this square root. So I've got 1 less square root to deal with. Okay, so I'm slowly cutting them back. I'll have to do the same technique again. So this will be x equals 25 minus 10 root x minus 3. So these x's will balance out. Let's see here. That'll make this 10 root x minus 3 equals 22. So now I can do the same thing that we had been doing in the previous, which was to square both sides. And I'll get 100 x minus 3. Now, I don't happen to have someone with a calculator do 22 squared for me. 484. Thank you. 484. Okay, so let's see here. 100x minus 300 equals 484. So that means x will be 784 out of 100. Now, usually these work out nicer, so I'm going to double check here, but it looks like so far I have an answer of 7.84 that I'd have to double check. But maybe let me just quickly make sure I haven't made a mistake. So that'll be 25, 5 times that, minus 5 times that, so it'll be 10, x plus 3, so that's okay. Maybe it's just a bad choice in the question. Maybe I could have picked some better values. So 25 minus the x's cancel. That's right? Okay. So then all we'd have to do is double check it in the calculator. So somebody with a calculator, can you double check those two, see that it adds up to 5? So we want to make sure root 7.84. Does it work? All right, okay. So maybe I could have picked some better numbers, but that's the technique. So let's try another one with the same technique. Okay, so we'll try this one here, which again, it's going to get a little bit worse before it gets better. So see how you do using your... That's a 3 if it's hard to see. Sorry, that's a 3. Yes? Yeah, that's fine. Yeah. Yeah, there's an email went out this morning. Yeah. Let's see here. So 2x minus 6 equals 6. 2x plus 1. So this one seems like it's turning out a little bit more of what's typical. So can someone confirm that for me, that 0 and 15? Okay, so if we end up with 0 and 15 to test out, let's try those in our equations, see what we get. So for 15, I get square root of 45 plus 4 minus square root of 15 plus 1. Is that equal to 3? So root 49 minus root 16, 7 minus 4. So yes, 15 will work. Well, let's also try it for 0. Square root of 4 minus square root of 1. And that's 2 minus 1. Nope, doesn't work. So 0 is rejected. We get an answer on this of x equals 15. Okay, so can I just see by 5 being the worst thing we've done, 1 being the easiest, where we're at right now? Do we need to keep trying some examples, or are we ready to... 5 is the worst, 1 is the easiest. So lots of 2s out there. Okay, so that sounds like it's time to go on to homework.